Okay, hello everybody. Welcome to our work group meeting. I see we have somebody new here. I see Bob Basarik has
Good
joined us. Bob,
afternoon.
you want to
Yes,
you want to say hello and introduce yourself to the group?
sure. Thanks for allowing me to join. I got this invite from Forrest Hare at SAIC. We are actually actively working with SAIC in a number of fronts. And when we talked about some of the work that we're doing in cybersecurity, thought maybe it would be fitting for me to at least listening to the conversation today. By the way of introduction, I'm Executive Vice President of Research and Development for a company called Newpush. We're a smaller company headquartered in Baltimore and Budapest, Hungary, and I represent presentations to organizations such as CCAA, NSF, and OCA certainly was one of the areas that we were looking into understanding if we can gain or add any value in participation. And maybe today would be a good background for me to understand how the forum conducts and see if there is anything I can contribute or gain from.
Well, thanks, Bob, for that great introduction. We could always use all the help we can get, Bob. So certainly enjoy you joining us here. This is our architecture meetings, which we'll have on a bi-weekly basis. We do discuss the underlying technologies and how we want to integrate security technologies across the silos that exist today. And we're looking at existing standards as well as establishing some new projects that will help us achieve that goal. So you'll hear a lot about some of those in each of our meetings. So thanks for joining us.
Thank you.
Okay, fortunately, so there's two vectors going on in this architecture discussion. One is one vector I've been working on with the OpenC2 team. I've been working directly with that team now to work on their EDR actuator and give them some more details on how I think OCA could work with them, both in terms of definitions they've already done as well as definitions I think we may need. And just to give you guys an update, the last thing I sent over there to the team was they were asking for me some use cases on especially the query response, although the person that was leading the EDR actuator said, oh, that's come up several times before, so it's not an unusual request. Everybody would be very interested to hear how OCA needs the query responses. So I sent them 3 persona use cases around the query response where we use sticks for context of threat intelligence feeds or SIM or SOAR flows. And so hopefully that'll help them get a little clearer. I do know when we work with them, we'll have to get into a lot more detail than that on what exactly gets sent and received between the two parties. But at least hopefully it'll give them a background of going down that line of how OCA and OpenC2 can work together for common command control and integration of some of the data flows we want to do on our architecture. So that's piece A. I'm going kind of down that line. And fortunately, I've had Dennis help me on piece B, which is, I think, most of this meeting. And piece B will be, if you remember on the last discussion, we said, well, we've got the nice use case for the malware detection and response, and it would be very appropriate and timely to add in EDR and NDR since XDR is such a hot topic. And Dennis volunteered to help me with that. And so I'm going to turn it over to him to lead the discussion on how do we approach that problem and what are the things we could do to kind of go through that process of extending both our architecture diagrams and data flows into those domains. So before I get into that, it looks like we have a couple of other new people. I think Ray Harris, Remco, I know you, Remco. Ray Harris and Remco also joined. Do you guys want to say hello real quick because you're new to the group?
Thanks. So I'm a cloud platform engineer and at IBM, and I'm also a developer advocate. And I'm interested in sort of the reference architectures around regulated industries. And I was joining the OCA meeting here to just to educate myself a bit.
Thank you, Remco. Thank you. Ray, you want to introduce yourself? Ray Harris?
You had it on mute. Yes, I'm from Newpush. Was talking with Forrest Hare this past week from SAIC, and he invited myself and Bob Bashar to join. We're interested certainly in some of the open standards and in interoperability issues that we understand you guys are talking about.
Perfect, perfect, perfect. Yeah, Forrest has been a great antagonizer of getting people to work with us, which is awesome, because Forrest is also heading up the OCA ontology work, which he probably told you about, which parallels some of the architecture work we're doing here. So
Yeah.
thanks for joining us. Thanks, Ray, and thanks for joining us, Bob. Appreciate it. Okay, with that, I'll turn it over to you, Dennis. I saw you started putting stuff up there before I interrupted you. I apologize for that.
Oh, well, delighted. First off, the marching orders on this were to look at EDR and look at what were the schema extensions we were going to need to do in order to be able to bring EDR functionality, at least with respect to the use cases, into the fold. To that end, I may have raised more questions than answers. So what I'm looking at in this presentation is identifying sort of the challenges and some instincts about them, and eliciting, hopefully from you guys, feedback on what's a productive way to resolve those with respect to our particular aims. But there are a few wrinkles that came up in the process. So let me talk about those. So the first thing I wanted to do was, of course, get a good bead on the scope of EDR capability, specifically with respect to how it's earning its keep. That is, what are the EDR functionalities being used, and how are they being used in order to justify what they do? How do they earn their keep, both in the market and in the communities of interest that are using them? Not how they do the things they advertise. That's there too, but that also changes over time in terms of the relevance and utility of those particular things. To that end, the 2 points of view on EDR that I used to sort of color things were the MITRE perspective in the broad sense, fairly simple definition, carving EDR up into a data collection capability, data analytics and forensics, threat hunting use of those data analytics and forensics, and of course, automated response as a consequence once you've decided that you've got a detection and you need to do something about it, facilitating that. Active response, I believe, is the coding that folks use in this part of the market to talk about that kind of capability. There is another perspective, of course. By far, the largest number of EDR products exist in the commercial space. And they have their own set of evolution going on. Gartner tries to characterize those, and they identified their key capabilities. The definition is slightly different in that Gartner's definition tries to admit the evolution of protection and endpoint protection mechanisms as sort of the direction that EDR had to head, and it's got some effect on how they view the world there, but also their definition of the scope of EDR to include file and file-less attacks. So artifacts not recognized by the operating system become part and parcel of an integral part of dealing with the threats in that kind of environment. Tons of stuff that are implications of that. The consequence, though, is a little bit different. We'll talk about that in a second. The EDR tools I looked at were these. With respect to what is the normalized view of how do we query or interact with an EDR tool and get stuff that's useful from the current EDR perspective. There was a point at which you use the EDR tool to essentially use an indicator or an observable of some sort to target artifacts and bring artifacts back to do something with them. That isn't how these EDR tools are being used today at scale. Part of that is because there's not a ton of expertise in dealing with the artifacts directly and as part of explicit workflows. A lot of that's being automated, but also an awful lot of the detection strategies and the capabilities to explain what's a consequence of those things to give you ability to act where the detection is at one level of abstraction, maybe on the endpoint, and the action may be at another, blocking things at an upstream firewall, requiring the knowledge of the topology and the relationship of multiple components, decidedly not endpoint centric. That has sort of forced bringing some things together. So you see an asterisk about the open source EDR tooling that's in this list. Those asterisks indicate that there is a multi-point perspective, a multi-endpoint perspective to the detection mechanism. So if you ask for a detection, it is most certainly not centric to the detection that occurs on an endpoint about an endpoint state and or behavior. It also heavily involves sometimes comparison or interactions with other endpoints. And so they become a significant part of the values that are delivered by these EDR tools that aren't endpoint centric in their identity or the ability to query them or the ability to take action against them. In fact, taking action requires knowledge of an awful lot in many cases of the topology in order to get there. So in this is part and parcel of a MITRE list augmented with a few of the open source EDR capabilities that have had to interact with substantially. I went through where they had APIs and began looking at those in some detail. And as you can imagine, there's a wide variance in what was there from the Wazoo stuff, which is a pretty solid API across a fairly basic EDR capability that derives from the OSSEC lineage, all the way across the board to what you might expect out of Google Rapid Response, also open sourced, but intended to work at cloud scale, very aware of the cloud hosting stack. And so doing things like differential memory capture across a few thousand images triggered by something going on in the stack at the application level is a very normal thing to do at scale on that kind of system. And so the APIs have their own models, and those models tend to focus on how the product looked at the artifact, how it looks at detection, and in that changes how you consume what you might think were equivalent kinds of indications, like give me a detection, give me a vulnerability, give me an anomaly. In all of those cases, they mean very different things with very different EDR capabilities coming out of them. So there is a question of how do we normalize that for OpenC2 communication intended to talk to multiple endpoints, for instance. But it got a little more complex as we started going a little further, and I decided, okay, well, let's look at what's going on in the commercial space. From Microsoft across the board. These are the leaders in the Magic Quadrant from the May or June 2011 Gartner analysis of who's got footprint, who's got ability to execute, and who's got the vision kind of quadrant. Well, these guys are squarely in market penetration, defensible market share, both growth and articulation of at least a sustainable vision. There are 13 additional folks that weren't in this top right quadrant that also were part of things. All of these guys have their own versions of what is the workflow that involves EDR, how well they embody it, in some cases, how well they make it opaque, so that your interactions are with the process and not with the artifacts themselves. Different semantics, different actions, and different integrations. The use cases that we had looked at were things like block an action, give me a file from a device, let me know something about processes on the device, that kind of thing, that low-level interaction. Very few of these make that something that happens without embedding in it their own abstractions or their own ways of identifying and marking the data in ways that make them relatively hard to compare. So the interesting thing is you get a resulting set of queries, a set of results, and a set of semantics, even when things look the same, that are highly balkanized. The different interaction models, some of them have very structured APIs, where the API structure itself is around getting files, getting processes, getting hashes, blocking something. But all of it aimed at sort of a relatively, what are the abstractions I'm dealing with, at the endpoint level in some of the cases. Others are at the query level, where all of that structure that was on the external API gets wrapped into a fairly simple API that submits a query, and all the understanding all the semantics are inside the query string itself, and dependent on its language and how it puts things together. Others create layers of abstraction on things like analyzers and essentially assume that you're doing an analysis for a particular purpose. It touches whatever it needs to touch, and you don't need to know about it. All you need to know is the name of the analyzer, which means in many cases, you don't know how it's using the underlying artifacts. That's all buried in the construction of the analyzer. And then a large number of them have gone into endpoint, as I suggested, recognizing that a primary indicator of anomaly might be inconsistency of endpoints that should be the same, but aren't. So comparison, the delta comparison of peers, like cluster members, or comparison over time, change that occurs that you don't have a good explanation for, become primary indicators of anomaly and become primary detection mechanisms in those. And so, of course, you're asking questions about sets of machines, not about individual machines in isolation. It affects the detection mechanisms, but also the action mechanisms as a consequence. Dealing with abstractions defined by the EDR tool that are relatively opaque if you just try to do sort of the query response kind of interactions with them. Then there's the different property naming and representations. This is not the toughest of the problems because there's often a way to get at the mapping, but it diverges as you start getting synthetic artifacts, the abstractions that the products themselves create and define based on the actions that they're doing, the groupings that they do. In many cases, they'll have organizations, and under that level, they'll wind up having groupings associated with a application or application scope. And under that level, there'll be a whole different set of things. And you're expected to be able to interact with those abstractions, but they get buried in also some of the definitions. Then the semantics vary pretty wildly in terms of the actions. Many of them make provisions for virtual patching, that is, blocking the exploit of a vulnerability upstream somewhere such that you don't need to patch it because it's not exploitable because you blocked it upstream. Well, the semantics of that depend very heavily on the topology, the relationship between that upstream blocking point and the thing that's acting. And for a supply chain attack, it has a very significant effect on the resulting posture. That is, blocking it upstream does nothing to keep supply chain inserted malware from doing whatever it's going to do within and before that upstream blocking action occurs. So there isn't much in these tools that give you much hint as to what are the semantics unless you know the tool and you know its architecture very, very well in order to bring that context to bear in interpreting what the result of an action, a simple action on the tooling would be. One way to get some insight into this is to look at Stick Shifter, which had the ambition of giving you a normalized way to deal with EDR tools at a point in time. And those EDR tools, if you look at the difference between interacting with Carbon Black and CrowdStrike, the adapters behind Stick Shifter have pretty wildly different sort of mapping to the underlying interface. About that point, my alarm bells start going off, and I started getting more introspective about the details. So for about 8 of these, I went through the APIs and looked at what were the differences in the APIs at those lower levels that were showing all of these differences at a higher level as I was looking at how to do the mapping. This is the Cortex 2 open source EDR capability used in the Hive project effort. Very not artifact centric. So you trigger things under the covers like analyzers. And only a few of them are directly identifiable as part of the artifacts that you're directly interacting with. The rest are embedded in these analytic processes intended to do a certain type of, for instance, detection capability. And what you interact with is those abstractions, which means that you need the vocabulary of the tool in order to interact further with them. That's not far off, however, of what happens when you start looking at Microsoft Defender for Endpoint, which has one layer where I'm very artifact centric, but a ton of the value of their EDR capability in this is on very idiosyncratic processing, grouping, policy mechanisms that are integrated in other parts of the platform and other parts of the security portfolio. Making it tenuous to think about, okay, what's a viable use case for somebody who has an enterprise license for Microsoft Defender for Endpoint for exactly what we have the ambition of putting together. An extended schema for OpenC2 interactions that trigger a fairly granular interaction with Defender Endpoint. So about that point, I started looking at the evolution in another dimension. Okay, if there is some evolution in how EDR systems are being used, where is that headed? Now, Gartner has an opinion on that, and it's based on what they see in terms of buying behavior and market footprint in the commercial sector. So in looking at those alone is one of the indicators. Their impression is that they're getting very rapid consolidation of the EDR market, of the network detection and response market, the NDR as well. Some consolidation to what is loosely termed XDR without a ton of definition, but sometimes is referred to as the fusion of NDR and EDR, recognizing that malware has behavior that is both network and endpoint at the same time, and that you ought get much better detection capability if you look at both network and endpoint detection simultaneously. But something echoed when you start looking at the MITRE attack matrix and you start looking at the behaviors that are modeled across attack life cycles, that you see a very broad spectrum of behavior that doesn't stay on one instrumentation point of presence. And of course, the managed detection and response, a very large part of the market has none of the expertise required to directly use EDR tools. And because of that, are taking advantage of that as a service with built-in expertise, managing both detection and recommending response, and that being moderated in some interesting ways. The changes in the market seem to facilitate this. Oh, I have a dyslexic-driven typo here. That should be 2023. That is end of next, well, 2 years from now. There's an expectation that cloud-delivered endpoint protection, which subsumes in this analysis EDR and NDR and XDR, will be 95% of all deployments. That by a bit longer, 2025, all folks using EDR capability, which will be subsumed in that EPP market from Gartner's perspective, will be using managed detection and response. That is, they won't be doing it themselves in an internal workflow, but will be facilitated by both the expertise and the workflows that are happening in another locus, that consumed as a service. And about 60% of the EDR solutions, 2025 also are going to use or bridge out to even more security control telemetry beyond just network and endpoint, but using those external control capabilities like data loss protection, the gateways, and identity in a broad sense, as they wind up having to look at more dimensions of mal behavior in the environment. So the real question is, are we really wanting to address this very rapidly evolving part of the space, EDR and how it's used, which seems to be very dynamic? Or are we in trying to standardize around that, extending the schema to do that, codifying interactions with that EDR at the endpoint level? Is that the right target at this point is just the question. And my concern, of course, is directly interacting with endpoints about files and processes and hashes and indicators. That doesn't seem to be the center of where EDR and endpoint protection are, or how they're being consumed, at least in the largest part of the market. So maybe making that the first question, can I get some insight into, is this completely off base, or are you guys seeing this as well, or am I missing something in terms of how we're constraining the focus of what we're doing? Just a question, and if you don't have an answer, there's a few more slides that we'll go into.
Oh, then I had a couple questions. I mean, some of it is of what you observed is the epitome of security. Everything is abstracted differently, different processes, different ways of doing things. So, what a surprise, right? I mean, that's always true. I think, what you observe here is also true, but I think, that's an evolving technology. I think you're going to find out on SIMs and SOARs and threat intelligence systems and analytics systems and everything else. So I think we're always going to have this moving ball you're talking about. And I think the way we can address it with OpenC2 is they have these different adapters. So there may be an adapter for, the old native EDR, and there may be another adapter for XDR, and there may be another adapter for MDR. I'm thinking that, kind of take into the evolution of where the different tools are at and map them appropriately. So at least I could say, I want to isolate malware, and I can talk on any of those lingos, mapping it to the right format as you're talking about in the right style, but at the same time, effectively take that action no matter what it is. That's my feeling.
And so I think that's the point, is that the abstractions seem to be changing such that EDR is not an endpoint centric technology as it's moving. It's actually a set of endpoints. And so the question probably isn't a question targeted at the endpoint, yet our use cases have the interrogation actually aimed and targeted at endpoints. So the question is, how do we bring the abstractions that the EDR now platforms are using into the picture so that you can use them to facilitate targeting the queries and or API calls that we're making, or the resulting actions that we're taking in the environment? It's not clear that these are endpoint to endpoint kinds of actions and reactions as EDR is being used in the market today, or at least as it's being used in the larger part of the market today. I don't know if there's a segment of the market that we're focusing on that actually does deal with the endpoints on a one-by-one basis in the way that the use case sort of described. Maybe that's what's missing. Does that make sense as a question?
Like I said, one comment I would make is just because you say EDR doesn't mean it's an endpoint. It could be a proxy to an endpoint, for example, for IoT, or a mobile endpoint for another. So I think the abstraction of the terms EDR, NDR, XDR, and so forth are going to vary by the implementations that a particular set of systems does and who acts on behalf of the endpoint, right? And how do they discover the malware is our example. So I think it varies, right? So the mapping will help us understand if I'm a part of our use case was, well, some of that malware came from an email detection system, right? Not even the endpoint, right? So that's okay. But at the end of the day, it's part of the stimuli I'm looking for the particular use case we're talking about. And it could come from a lot of other places too. We only picked the two, and there's going to be more. But there are certain things that recognize that you've got a problem with the malware. We just picked those two examples. And there could be multiples of them, I think. And there will be multiples of them. And as you're discussing, the nature of what we're talking about here, they could also be places where such a thing can happen, right? The discovery could happen from each of those.
Yeah, and so the place that I'm getting hung up is in looking at our schema and extending it. We need identifiers for the topology, not just the endpoint itself and its telemetry and instrumentation. Because, for instance, the NDR part of the EPP part of the market, the place that EDR is rapidly evolving to, is all about the topology and not about the endpoint point presence itself. It seems that the model has to be broader. It seems like
that's true.
We're protecting a system rather than an endpoint, if that makes any sense.
No, but it does certainly make sense. We did purposely not put in that level. I mean, that firewalls came up as an example. They're not a church, but absolutely, I think you're right on that. We'll have to extend. We'll have to, take that level in here. And that's probably what we should do as part of what we're doing here. Is starting to extend that out to some of the physical you're talking about, because that was purposely not done in the beginning, to simplify things and just provide some focus. But it's valid to go way beyond that, right? Because it's not just the things we've described that are more software oriented. There is some other physical resources that I think are going to find malware or symptoms of malware.
So I think that's got the finger on the pulse of my concern. I'm not sure the first step in that direction is endpoint centric, and that is a tactical step in the strategic direction of the system side of the fence. I think there is probably a need to think about how do we look at the protection of the endpoint that is a consequence of both the context of where it's located and what it's interacting with. That the second you do that, you create the opening to go to that broader, longer term direction, and
Sure.
What I'm worried about is focusing on just the endpoint as one step seems to limit things, but it's limiting things based on where EDR is, how it's used now, and what's happening with it and how it's getting consumed.
Yes, I see what you're saying. Yeah, I don't think that was the intention. I think it was just the first phase pass. So I think that's fair, Dennis. I think the intention was to go a little broader than that.
Okay.
So Dennis,
go ahead.
yeah, thank you for bringing all of that up. I'll make an analogy. Earlier, 5 years ago or so in OpenC2, we're trying to bring value by having, open interfaces. We were dealing with Phantom, an orchestrator vendor, and they had to build in all sorts of adapters into their products to work with different endpoints. And we thought OpenC2 would be a way for simplifying orchestrator development if there was a way to have a common interface to the different types of endpoints that orchestrator products needed to deal with. If 90% of the market is going to MDR now, and end users aren't going to have the expertise to do their own network defense, then the people that we need to be asking where is their pain point are the MDR vendors. And if for a single MDR vendor, they're going to have to interface to an entire network. And I don't know whether they have whether they're having to build multiple adapters to do the same thing or not. But I think it sounds to me, just off the cuff from hearing what you're saying first time, is we need to be looking at the pain points for MDR providers. And if we can't talk to them or discover what those are, we may be, dead in the water about trying to provide value.
Dave, do you know if Phantom adopted OpenC2 then? They're actually integrated into Splunk now. Splunk bought them.
Right. And when I think they went through probably 3 or 4 companies before Symantec and Broadcom. And so no, we have had lost contact with Phantom a while back.
All right. Well, I mean, we have SIC has a strategic partnership with Splunk, so I'll ask my Splunk interface team to see if Phantom's actually using that, and then that might be a useful leverage point for us. Thanks.
So that is another dimension that makes complete sense to me, is that if I took something like Phantom and integrated it into Splunk, then you've got all that semantic connection sitting there. And the questions you'll ask about the endpoint will be informed by a ton of what Splunk is being able to connect the dots across, if that makes sense. And that gets to where I think this probably heads, but let me go through a couple of other items. And
we're not semantic yet, and neither is MITRE, but we'll have a discussion later. Neither is Attack Matrix. I've tried to assess it. We can make it happen.
I'm encouraged. So in all of the EDR, NDR, XDR solutions, and a lot of the MDR process, there has been a leaning to mapping to things like attack. And the reason is because it connects the dots across modalities, across instrumentations, but coherently to malware behavior. The malware action having lots of dimensionality to it, some of it being compute, some of it being access to data, some of it being network oriented, or at least communications channel oriented in some way. In that sense, it becomes a unifying mechanism that lets you connect the dots across multiple sensing modalities, improves the signal to noise ratio, and does a lot to give you context. It seems like that very bridging of those modalities becomes very, very useful, but it also is a cross-cutting similarity when I look at all of the EDR tools, that they're all doing the mapping to the MITRE attack matrix, partially to participate in the sort of evaluation of efficacy, but also to establish for themselves their coverage of the attack footprint in ways they haven't looked at prior to that. There's also a very broad platform relevance to all of this in terms of looking at things at the enterprise level, that is all the stuff that's there and the domains across which they interact, as well as the operating system, the cloud, the network, the container level, and mobile, and you get the picture. But across endpoints as well, there's a clear recognition of the interactions where reconnaissance and lateral movement are occurring and how those behaviors are codified. So the bigger question might be, should we be considering the interaction with a system that is the EDR system that has its abstractions, its connections to policy, its differences in detection mechanisms and the ways in which that stuff occurs, so that what we can provide is that thing that we know in that simple interaction sense, the particular asset that we're talking about. Providing that to these systems allows them to bring all that stuff to bear. All of the detection functionality and all of the abstraction that they've put in place that is really part of a platform, but that also is the stuff that's interfering with us getting at the artifacts themselves. For instance, the file itself, absent all the other stuff that wraps around it, and all of the policy that's controlling it, and then the provenance of how it got there. All that contextual stuff is actually pretty visible to the EDR systems in their integration across the portfolios. Maybe it would be easier than trying to normalize the instrumentation on the endpoint and trying to get directly at sort of giving them an indicator and getting back a list of artifacts at a much lower level, where the EDR system that controlled the instrumentation indeed hasn't added its value add to it, its detection, its control, its topological awareness. All that stuff doesn't exist if we can do the original task of having a very simple interaction to some instrumentation on an endpoint that tells me about files and processes and hashes, and maybe does some action on that endpoint, but does nothing else, right? And just the suggestion is that EDR seems to be becoming that broader endpoint protection system, not the instrumentation on an endpoint in isolation, and maybe not the right target to try to normalize our interaction to. That's just a suggestion for consideration. I'm very open to counterpositions and explanations for why I'm wrong about this kind of observation, but that's where I sat. I've got a ton of data behind this that might be useful, but I'd be really interested in feedback and reaction to that as it sits.
I had a question, and maybe I'm joining this conversation way later than many of you. Where do you see the convergence of the endpoint and network devices to be? Is that something that is considered as a part of the mandate of the MDRs, or do you see that as being out of the scope of the MDR as a whole?
No, I think it's a consequence of the natural progression of both NDR and EDR in their independent markets. The EDR tools have been doing everything they could to do detection on the endpoint and to provide mitigations there that were relatively automated, but were largely uninformed by the network topology that surrounded them. At the very same time, the network detection and remediation folks, think last line and those guys, very good at detecting network behavior, but because they knew very little about the endpoint, didn't get a lot of resolution to an awful lot of activity. If you step back and squint just a little bit, though, you realize that, that malware that's creeping through the enterprise, however it got there, up the supply chain or whatever, has both network and endpoint behaviors. I think it is a very natural technical evolution for us to say, those two behaviors, when you put them together, give us a much higher fidelity of detectability because they've got more modalities of behavior to detect against, a longer sequence of interaction. I can get much higher signal to noise ratio in doing that detection. And we've seen that in some of the higher level behavior detection kinds of systems. So I think there's a natural driver there. There's a business driver, as you suggested, that when a customer consumes protection, if they're not very sophisticated about or don't have the staff or the resources to handle operating EDR by themselves, they probably don't want to be bothered with the difference between EDR and NDR. They want protection. And so the MDR value proposition you could see being driven by a customer who's saying, whatever it takes to protect my systems, that's what I want to buy. And that eliminates the boundary between those, fairly artificial boundary between those two kinds of technology, if you will. So I think there is a business driver there as well that says the guy providing the service now has the problem, and he wants less friction, less impedance mismatch, less tools to deploy. And so I think that is a driver for the same consolidation. I think the broader market, because of the manpower challenge, is looking to consume services because they simply can't hire staff and train, much less sustain staff that can handle sophisticated protection capabilities. Consumption as a service makes sense in that domain as well. Does that answer your question at all?
Yeah, absolutely. That's exactly the angle I was looking at, and I'm not so sure if you guys have evaluated FireEye or not, but FireEye at some point wanted to converge their capabilities that was network-based and the endpoint-based, so that it actually conform to the same platform following the same standard. Obviously, they're two different beasts altogether, but they fall short because one of the areas where network is really hard to recognize whether it's acting normally or abnormally depends on the characteristic of the network, which differs from industry sector. You know, it's quite differently analyzed, and it doesn't have the direct correlation to that of the endpoint within that network. And that to me was one of the areas that I personally haven't seen any companies that had put forward a strategy how to align and orchestrate between the two in much effective way than it is done today.
I think that is one of the prime motivators for instance, the impetus behind Zero Trust, where compartmentalization of a relatively flat network, but segmentation applied at the application/container level does give you that normalization of sort of networking and compute and the relationship between them at a granular level. So having to get at all the nuances between the relationship of those two different modalities becomes a lot more focused if you know exactly what you're protecting and it's fairly small and you know exactly how it's being connected to. But that applies where you can divide up an application into relatively small parts. It's still a very messy world for an awful lot of relatively conventionally architected applications. And those have exactly the problem that you're describing. Hard to get coherence in what you're seeing unless you happen to be pulling on the right abstraction.
Yeah, I mean, 100%. And the other thing is that in my past experience, part of analyzing the behavior of either network or endpoint related to understanding the deviation of it to a known set of baseline that gets demised by looking at a network, observing its behavior for a period of time before, creating that baseline. But that also has its own flaws because given, you have a period of time to observe the given behavior within the network, who says that that's a normal behavior? Who says it's not a compromised network? And that itself can start on the faulty foot. And to me, I think that is the risk, because I've heard you saying that beginning of the discussion, you opened up by saying that there's a normal path to recognition of the what is deviated from normal in many of the EDRs. That to me is also another area where I've seen challenges in many of my previous work of defining what defines normal.
Absolutely.
And that in large network is a lifetime project.
It can be, especially if you're trying to do so in a very complex environment, and in an environment where all you have is observed behavior, where you don't have any intentional behavior or any intentional structure to the network. Without those two things, what you get is an unexplainable anomaly as a consequence, and that leads to really nasty problems.
I would also say one of the interesting things about that point is the more context you have around other systems, like user behavior in analytics, for example, the more you can get a better understanding of what that behavior is doing, right?
Yep.
So part of the anomaly of security is most of the systems that we're looking at are single siloed, single viewpoint, therefore very biased perspective on what you see, right? And until you get a more composite understanding of how that information is being used across these different environments. And zero trust is a great example of that. Is,
yep.
Welcome identity access management to data security management. It's about time we pulled those together, huh? And right. And XDR is, hey, welcome extended networks and endpoints. So I think what we're seeing here in security is that maturation of you need to have multiple perspectives of context so we can pull together information to get that better view than the current fuzzy view we have, which is too myopic based on a single tool.
So to that point, I think there are two places we can go here with respect to the objective that I was working on. The first is we can say it's not the broader intention of EDR, but a much narrower one that says, I just want to know about files, processes, hashes, and the blocking actions that can happen on the endpoint, whether or not that makes sense for the rest of the system. If we do that, we narrow the focus and it becomes easier to extend the schema to in a way that we're already set up for to do this. That doesn't get to the maximum value, and it says you're going to be doing a lot of other kinds of interactions with a lot of other kinds of tools to support sort of modern protection and defense response in some way. But this one would be simple. You can go the other way and say, recognize that EDR is becoming a system precisely from some of the reasons that we've just described, that it needs multiple vantages, that an endpoint by itself is not the best place to detect whether an endpoint is compromised or not. It needs the rest of the context brought to bear. And as that occurs, what our objective is, what we want from the communications to those systems changes. It's higher level. It's not just about the endpoint, and it needs some context with it. And that's a more complicated expansion to the structure that we've been talking about, but it is one that does track with how things are evolving, both the need, the potential solutions, and the telemetry sources that we have to interact with. I think that's the question that we're at as a consequence of this.
Right. I think actually we're going down both paths, if you ask me. I mean, I'm kind of chasing that very specific EDR path with the OpenC2 people. Right. And so, I'll keep going down that line. But, if you could take the second line, the more broader line, let's take a look at both angles and see, how we can evolve the architecture to the more broader problem you're talking about, which I think is extremely valuable. But at the same time, let's follow through on what we've got at the simpleton level, right down all the way to the, there's a reason why the OpenC2 has an EDR profile, right? So let's go into that and investigate why that's true and how that helps the OpenC2 group and what they're doing.
Now, I tried to see that profile by going at least to the site and didn't get past sort of the four nascent files that were there.
Yeah, David can point you to it. It's not committed yet. It's off in a branch. So yeah.
Got it. Okay.
Yeah.
So yeah, if I can get some insight into that, I can figure out both how to try to bridge that without breaking the other, if that makes sense. But,
okay.
I don't want to oversell that either.
Right.
One guy has been working on the EDR profile, from University of Oslo. So I will not say that it's very comprehensive or mature yet. It's
a start.
Even when we find the correct branch, it might not be very informative.
Fair enough. But I think it'll educate us on a perspective, which is useful.
So OpenC2 is focused on the response piece, of course. And so regardless of where your threat detection comes from, at some point you decide you're going to have to do something. So is there Dennis, do you see a convergence or a small problem to tackle in the response piece?
Certainly a much smaller one. And that is because the analysis has already been done. You've come to a conclusion and you're deciding now what the response is. Is it a mitigation at the endpoint or is it a remediation? And if it is not either of those, then it might be a mitigation upstream somewhere. those mitigations, if it's topologically based, you need to know something about what the effect of doing it where is. And then there's the extension case. If I found it here, where else might it exist? And so what do I do more broadly? The response question isn't super complex. And it does depend on, do we scope in mitigations and remediations that aren't at the point of detection, that aren't change the endpoint itself if it's detected at the endpoint itself. That could be simpler, but I don't think that's all of how things are done sort of at scale in this stuff. You know, an awful lot of folks are hugging an immutability strategy in order to be able to do the mitigation back in development and release a now mitigated version, and in the meantime, containment, confinement, or shifting to a previous version winds up being a mitigation action. Those seem more complex though than the use case that we've been thinking about, which was, you know, block at a firewall or keep something from launching. Those are kinds of actions that are certainly simple to accommodate. It's just I hadn't seen them emerging as dominant in the consumption analysis that we're seeing from Gartner about EDR and the evolution of it. So all I really needed to know is, where does it fit in the use cases, and sort of what's our ambition for extending the use cases. In both cases, you kind of want to know how you're getting from where you are to there. To the extent that we can get some insight into what's the real scope behind the use cases or the work in the OpenC2 environment of that profile for EDR, just the driver behind it, that would let me know an awful lot about where I'm coloring inside the lines or maybe getting too far outside of them.
Now, Russ said he would pursue the endpoint centric piece. You know, I'm more focused on the response piece and how we can, you know, whether it's containment or sandboxing or you know, detonation, or those are the things we've thought of already. But yes, not necessarily endpoint focused, endpoint mitigations.
Do you have a workflow that covers the response scenarios that you're typically most focused on, that's something I could look at?
No, that's what we're learning from you.
Ouch.
Well, that's
okay, I'll get better at that.
Yes. Yeah, dig in.
We have some use cases from which you can expand, right?
Yeah. Okay, I'll take the use cases, lay them out together, and see if I can cobble together a workflow that makes sense from those, and then try to normalize that to maybe some of the playbooks, which will also help broaden those. All I'm looking for is something that fits into sort of where the way that things are moving, not just sort of the point in time, if that makes sense. And I know we can make headway on that. In the meantime, I'll send out this deck. It's intended to elicit response. There is no religious ownership to this thing, so please don't hesitate to add whatever feedback that you have in this, or pointers to folks if you think we ought to get more informed input down.
And I put in the chat, Dennis, the link to the EDR draft from OpenC2.
Oh, great. Let me get that before the...
Grab that. That'll give you some data.
Page that window. There you are. Thank you.
Yep. Well, thanks, Dennis, for taking us through that. Very, very, very helpful. And I do love the broader idea. I don't know when you think we could do it, but I'd love to get a pictorial view of what you're depicting here, because I'm a picture kind of guy. So I would love to.
Yeah, I am
see if
too.
we get a layout.
It just I picked so many data sources that it was a little tough to distill it.
Right. Well, now you can take those data sources and make a massage them and process them. What do you think?
So in my 5-minute update next time, I'll have a diagram for you.
Perfect. I just helps me a lot. I don't know about you guys. But thank you, Dennis, for all the work you did.
Sure.
Any other questions or comments?
Welcome to Bob. I assume Bob introduced himself. Sorry, I was so incredibly late on site with DIA here, and we had a meeting that ran long. Okay, good.
Yep. And another fellow was here too.
Thank you for having me today.
Yeah.
Yeah, Forrest,
It
you
was
brought
fun
two
work.
people in. Thanks.
Yeah,
Well,
he
Ryan,
left
was
early.
Ryan with him? Okay.
Yeah, somebody else showed up and he was here for about 30 minutes, 15 minutes. Yep, that you sent over. So yeah, two people showed up that you referred to here. So great. We love all the help we can get.
So thanks, Dennis. That was wonderful.
Thank you, Dennis. Yep, very, very appreciative. Appreciate it all. Thanks, everybody. And it's right at
Thank
5
you.
o'clock. I'm getting really good at these meetings. So we'll see you guys next couple weeks.
Thanks, Russ.
Thanks.
All
Bye.
right, bye-bye.